Hi all. Today let's see a question from GATE 2020 ME paper 1, question number 28. So you are being given bars of square and circular cross section with some particular length and a shear strength. Okay. So now the cross sectional area is given of both the bar and the rod. The specimens are supposed to be loaded in these four cases: compression, torsion, bending, tensile. So the question is, which specimen or specimens will fail due to the applied load as per maximum shear stress theory? Uh, so these are the options given. Okay, so this is even though it's the problem about maximum shear stress theory, you need to know few basics about what is the shear stress for when it is in torsion or bending. Okay, so before going into details, if you want to know more detail about all these concepts, you can look into mechanics of solids course by Professor Priyanka Ghosh, IIT Kanpur. Okay, so let's see. Yeah, so these are some of the useful data. That is, when you have tension or compression, you are going to get the stress which is equal to F by A. Uh, Here, their both signs are different. That's it, because one is tension, one is compression. Similarly, if you have a rod, you are going to get shear stress to be TR by J, and here the bending stress of the bar will be my by I. So these are all sigmas. How we will get tau is basically sigma by 2. That's it. Okay, so let's look into the problem. So here is the problem. Okay, so let's name these cases: 1, 2, 2, 3, 4. So let's take case 1. Now this is the simple case. You are having a rod like this which is under tension. You have a bar, not a rod, and so this is a simple case where you are having a bar like this with 80 kilonewton force. So your stress is given by F by A, which is 80 into 10 raised to 3 by your area. So your area was given by 4 centimeter by 4 centimeter, right? Converting it into mm, so you get something like this. Therefore your sigma is going to be 50 MPa. This is tension. Okay, now according to maximum shear stress theory, you need to use maximum shear stress theory to actually find the failure point. So what is your maximum shear stress? That is, let's say your tau is equal to sigma x sigma y by 2. So here you have only one sigma, so let's take, so this is 0, so tau is equal to sigma xx by 2. So here your sigma and sigma xx is same, so that means you are going to get 25 MPa. Okay, so your first case, let's say tau 1 is 25 MPa. Okay, now let's go to the second case. Second case is pretty straightforward. Again, it is compression this time with the same 80 kilonewton. So without wasting much time, you can directly write your sigma to be 8. You can write your without wasting much time, you can write your sigma to be, how much did we get? 50 MPa. In this it is compressive. Okay, so from here again you will get your tau 2 to be 25 MPa, right? Okay, so now the interesting case, that is third case. You are having a rod which is under some torsion, which is given as 64 pi Newton meter. Okay, so now you will have shear stress given as Tr by J. Now here your J is actually polar moment of inertia. So if you have a rod with radius r, so its J is given to be pi r raised to 4 by 2. Okay, so using this here, what you get is T r pi r raised to 4 by 2 to 2T by pi r cube. So in the problem it was given that its diameter is 4 centimeter, 40 mm, so its radius is 20 mm. Using this data and this, what you get is 64 pi 10 raised to 3. It is you're converting this meter again into this 2, let's say, by pi into your r cube. So when you solve this, what you get is this is equal to 16 MPa. So this is your tau 3. Now let's go to the fourth case. Fourth case, again you are getting some bending from 320 Newton meter. Okay, and here the area is again 40 by 40 mm bars. Okay, so now here, because of this you are going to, because of this bending moment, we're going to get some bending stress, which is my by I, like in previous case. So here your I is again going to be a raised to 4 by 12. That is, if you have a cross section of square, so its I is given by a raised to 4 by 12. Now your y is actually a by 2, that is the distance of maximum stress from neutral layer. So what do you actually get is sigma is m, here a raised to 4 by 12 a by 2, which is equal to m by a cube by 6. Okay, so substituting this value, you are going to get 320 into 10 raised to 3. Substituting this value, you are going to get sigma b is equal to 30 MPa. Okay, now again what you're going to do is use this and find your tau to be by 2 15 MPa, right? So now what happens is, take all the 4 case, that is you have tension, you have compression, torsion and bending. In this you got tau to be 16 MPa bending it was 15 MPa, and here both you have 25 MPa. Now in the problem it was given that its shear strength is 20 MPa. So anything greater than 20 MPa will make it fail. So that means your answer is TNC, that is tension and compression. So let's look at the options. So here is your option. So your answer is A, tensile and compressive load. So I hope you understood this problem. This was a very good problem with so many concepts involved. So thank you.